In today's video, we are going to deal with velocity of vehicle on curved bank road. In a previous video, you must have seen that we have derived the velocity of vehicle but on horizontal road. Now, why banking is necessity or what is the necessity of banking that we have described in short in the previous video. Remember, when we consider that vehicle is taking turn on the curved circular track, frictional forces plays very important role. Okay, but now if you remember, I have told you that frictional forces cannot be permanently remain same, because if suppose the rainfall takes place, then surface will get wet. Because of that wetness in the surface, the frictional force is definitely going to be reduced. In that case, what should be the effective speed for that road? That will depend completely upon that frictional force. So we have to do some modification while constructing the road. That modification which are necessary to construct the road are called as a banking of road. That modifications are considered as what? Banking of road. So what is the banking of road? In short, banking of road, I have drawn diagram already to avoid the wastage of time. So what is banking of road? Elevation of outer edge of road over its inner edge is called banking of road. Means what? If suppose these are the two surface, these are two levels of the road, this is inner edge of the road and this is outer edge of the road, then they both will not remain parallel exactly same. One will be inclined by certain angle. So if this is the surface of road, then during banking it will be elevated by certain angle. So you are expecting this is the horizontal surface, but now after banking that road will appear like that. So it will going to form certain angle between that. So this will be the inner edge of road and this will be the outer edge of the road. So road will not look exactly leveled, it will be look like slanting. Okay, but we are not going down, we are moving on that slanting road like this. Okay, so consider such small certain vehicle and road is banked with certain angle. So this angle theta we can call it as angle of banking. So let m be the mass of vehicle, m be the mass of vehicle moving along that curved bank road. Say V max is the maximum velocity that can be expected to travel by the vehicle. Few things that we should mention. Say Fs is the frictional force present there, it is because of static friction. Say mu s is the coefficient of friction which is present there, and finally that curvature of road has radius r, so let r be the radius of curvature, r be the radius of curvature. Now see, I have shown that road is having turn like this and vehicle is going say towards that, so vehicle is directed in this direction, this is direction, vehicle started motion and going like this. Okay, now what is happening with the vehicle? The forces acting on the vehicle are very important. We know that when we are standing on any surface, our weight is one of the important force, and that force is balanced by the normal reaction. So forces acting on the vehicle are: first force is due to normal reaction, and that normal reaction, as we know, it is caused by weight of the vehicle or weight of the object. So this normal reaction is further resolved into, why it is going to resolve? Because now vehicle is not on the parallel road, this is not the vehicle is now on the slanting road like this. So this is the angle theta and now there is the vehicle. Because of that, this will be the direction of normal vector normal reaction n, so it is automatically going to resolve into two component. Like already I have shown, one component is n cos theta, another component is first component is n cos theta and second component is n sin theta. So normal reaction resolved into two parts. The first component is n cos theta, which is vertical component. I think you know how to find components. If this is angle theta, then this will be the theta. So if this is angle theta, the component along the angle is the cosine component, the component perpendicular to it is the sine component. So it is the vertical component, and second component will be the n sin theta. N sin theta will be horizontal component, and this will be directed toward the center of the curvature. Okay. Now along with this n sin theta and n cos theta, there is a friction between road and tires of vehicle. There should be what? Friction between road and tire of vehicle. That frictional force will be always towards the center or toward the inclination surface when we are finding maximum speed, because to find maximum speed, that frictional force and centripetal force should be towards same direction. They should not get opposed. So we will get maximum velocity. Now if we are moving with minimum velocity, if we want to find out minimum velocity, then frictional force should be opposite to the curvature or oppositely directed to what? Curvature. Okay. So this thing we will discuss later on again. So frictional force is inclining again by angle theta. So if it is inclining by angle theta, then cosine component of frictional force and sine component of frictional force will be represented. So second force is acting there is the force of friction. Second force is acting there is what? Force of friction. And this force of friction is again resolved into Fs cos theta along the curvature, along center of curvature, and second is Fs sin theta along weight of the vehicle, along weight of the vehicle. Now what we are going to apply the logic? See, everywhere to produce circular motion, so if this is the force of friction, then that force of friction is again resolved into two component, force of friction Fs sin theta and Fs cos theta. The same diagram can be represented in short like this. Okay. Now see, the facts are n cos theta directed upwards, whereas f sin theta and weight both are directed downwards. When they both will balance, if this is n cos theta and this is n sin theta, when they both are balanced, then only vehicle will be moved stabled. So no external upward force and no downward force. The force will be exactly steady, so that vehicle can only proceed in the forward direction. So we can write one important term, that the component n cos theta is balanced by two parts. What? Fs cos theta and weight of vehicle. So the component n cos theta is balanced by what? F sin theta and weight of the vehicle, Fs into sin theta. So if I write this in the mathematical form, then how I can write? So n cos theta is equals to sum of these both components. So Fs into sin theta plus weight is nothing but mg. So just adjust the some terms. This plus will be shifted here and this mg will keep. Therefore we can write mg is equals to n cos theta minus Fs into sin theta. Say this is the first equation what we required. Now we are moving along the curve track. when we move along the curved track, which force is required? Yes, definitely we require centripetal force. Now, which component of forces are responsible for that? Then yes, again I will say n sin theta and f cos theta. Why? Because they are along the direction of the center of the circle. In that case, we will say, if I want to write the component n cos theta, sorry, not again n cos theta, the component n sin theta and fs cos theta provides necessary centripetal force for circular motion. So, as we are finding maximum speed, therefore we can say mv square max upon r, that is centripetal force, should be provided by these both, which are both n sin theta plus fs cos theta. Say this is equation number 2. Okay, now the basic explanation is done. We just need to simplify, elaborate those terms. Divide equation 2 by equation 1. Dividing equation 2 by equation 1. What we are going to get here then? mv square max upon r divided by mg is equals to n sin theta plus fs cos theta divided by n cos theta minus fs sin theta. M get cancelled, so that what we remain on LHS, v square max upon rg is equals to n sin theta plus fs cos theta divided by n cos theta minus fs sin theta. Now, simplifying these terms by using the laws of friction. If you remember, boys, girls and students, by laws of friction, we have fs is equals to mu s into n. So if I put here, instead of fs, if I put mu s, then what we are going to get here? Now, v square max equal to rg in bracket n sin theta plus mu s n cos theta divided by n cos theta minus mu s n sin theta. This will be the term, okay, equal to rg. R is small as we have shown earlier, so we will use that, will not make any difference. So rg into, see, n will cancel on both sides, numerator and denominator, so it will remain what? Sin theta plus mu s cos theta divided by cos theta minus mu s sin theta. Okay, this is value of what? V square max or V max square. Now, the term in the bracket, let's divide it by sin cos theta to the numerator and denominator. So I will write directly now. If this sin theta is divided by cos theta, then it will remain tan theta plus mu s cos theta upon cos theta. So cos theta will get cancelled. So tan theta plus mu s will be remain. This cos theta upon cos theta will be 1 minus mu s sin theta upon cos theta is what? Tan theta. So this will be the value of V square max or V max square. Therefore, V max can be equal to root of Rg tan theta plus mu s divided by 1 minus mu s into tan theta. This formula is considered as the formula for maximum safety speed of vehicle moving along curved bank road. Okay. If you want to find out minimum safety speed, for minimum safety speed, the direction of this frictional force will be along this line. In that case, this 2 means what? N sine theta, and this Fs cos theta will be in opposite direction. In that case, everything is going to remain same. This plus sign is going to be replaced by minus sign, and because of this it will be like tan theta minus mu s. So you just try to go draw the diagram. Tan theta minus mu s divided by 1 minus mu s tan theta will be giving us the minimum safety speed. Now, what is the safest or most we'll say optimum speed? Most optimum speed, most desired speed we want to find out. To find this, remember frictional forces we shall take 0, since vehicle do not experiences friction. We consider that they do not experience this friction. Frictional forces will be, say, instead of exactly equal to 0, say approximately equal to 0. So if I put there, then what will happen in this equation? This mu is going to become 0, this is become going to 0, so everything is going to cancel. So say V is equals to root of Rg small r Rg into tan theta plus 0 divided by 1 minus mu 0, sorry, it is again 0, and into tan theta means it will be 0. So finally what we are going to get is root of Rg into tan theta. This will be the most safe speed. If you travel with this speed only, you will be covering that circular track without any problem, without any issues. Now from this formula, if I square this, then we will get V square equal to Rg tan theta, implies tan theta is equals to V square upon Rg. Then we will get one more important formula here, that is equals to theta equal to tan inverse of V square upon Rg. Now this will called as the angle of banking, formula for angle of banking. Using this theta, one can find how much height is elevated. Okay, so students, this is the important article. What we learned today is very essential for CET. Okay, so these things which I am going to mark now. First thing here, that is normal reaction, which is resolved into two parts. This is the first part and this is the second part. Vertical component and horizontal component. Similar for frictional forces, it is also going to resolve into two parts. Now frictional force and weight directed downward and normal reaction directed upward, so they both has to balance each other. Upward component has to balance the downward component. In that case, we are going to get this first equation. This is very important equation. Okay, then the components n sin theta and force component, frictional forces, are towards the center of that radius of curvature or road. Then this second equation will be very important. This plus sign indicates that vehicle is moving with maximum speed. If vehicle is moving with minimum speed, instead of this plus sign, it should be minus sign. We have divided equation 2 by equation 1, so that we got this important equation V max. V minimum I have written, and you just need to go help yourself to draw the diagram. Now what is the most optimum or most safe speed? For that, friction should be very small, so we took it 0. So vehicle is not experiencing the force, experiences not experiencing friction. So V optimum, VO, is equals to root of Rg tan theta plus 0 divided by 1 minus 0. So V equal to root of Rg tan theta. V square equal to Rg tan theta, so that we will get theta equal to tan inverse of V square upon Rg. This is the article that what we have covered today for your CET. It's one of the most important article. Thanks for watching mahasarkar.co.in. Have a nice day. See you again.